All right, so here, let's consider now when the angle is 30 degrees. Now, what they actually show what they do consider in the textbook first is a 30, 60, 90 triangle. So here's the angle 90 degrees. What I'm going to do is say this is 30 degrees. The hypotenuse is 1. And then, of course, the remaining angle is 60 degrees. Let me just fill that in. Okay, now, if the hypotenuse of this triangle is 1, they actually do show it in the book. It turns out the side opposite 30 degrees is a half, like so. And the side opposite 60 is radical 3 over 2. So in other words, we get this right triangle. I think what they actually do is they take a copy of the right triangle before we know the side lengths, of course, the missing ones that is, and they put them together to form an equilateral triangle. But it's not terrible, but it is in a book. But once we know this, then we can actually figure out sine, cosine of 30 degrees and 60 degrees and so on. And you'll actually see that the values you get in right triangle trigonometry do carry over here. Okay? So for instance, let's draw the angle 30 degrees. What we're going to do is draw it in standard position. So let's draw that, and what we get is this. So here's see if I can draw the unit circle. Like so. So again, I'm drawing an angle of 30 degrees in standard position. So here's the initial side. The vertex is at the origin. Here is the terminal side, okay? So this angle down here, yes, it's theta. I'm going to label it, as 30 degrees. And now how does that help us? Well, let me see if I can draw it. What I can do is draw the line from the point P. P remembers where the terminal side intersects the unit circle. So what we're going to get then is this. So this side I'm drawing from P to the initial side, and it's going to be 90 degrees. So in other words, what we have is this triangle. From here, see if I can draw it, make it bigger. There we go. And now, so we have this. P has coordinates x, comma, y. Wait, there we go. Okay. Actually, let me just make that a little bit nicer. Just to make it easier to see, okay? So P does have coordinates. Actually, got a better idea. Let me do this. Let me draw it up here. P has coordinates x, y, okay? The hypotenuse has length 1, okay? Because again, we're working on a unit circle. This side here is 90 degrees, okay? Now, this side here, right? That's the height of P above the x-axis, right? X-axis, y-axis. But the height is given by the y-coordinate. In other words, this triangle here, the height, is y. Now, how far P is from the y-axis, right? That's what the x-coordinate gives us. So this is x. So again, x, right? That's how far the point is from the y-axis. That's exactly what this length is. And the height from P above the x-axis is the y-coordinate. In other words, what I'm trying to say is the length of this, the height of this triangle here is y, as I labeled it here. The base length is x. And again, this is an angle in standard position of 30 degrees. So this is 30 degrees, right? The top one here is 60 degrees. But hopefully you can see that these two triangles are actually congruent to each other, okay? They are congruent to each other. Now, what does that tell us? Well, that tells us that, for instance, x equals radical 3 over 2, and y is 1 over 2. So in other words, we have the coordinates of x and y for P, and now you can get sine and cosine of 30 degrees. And so basically, because of that, you get the same values as you would for SOHCAHTOA. And really, it's the same kind of argument if instead of 30 degrees, you had 60 degrees. I mean, the triangle might look different, but it actually is the same triangle you get. Okay? Good. All right. And, excuse me. And in fact, if you remember how one derives what sine and cosine of 45 degrees are, they actually use a special kind of triangle for that. Okay? Let me just erase this. What they actually use is an isosceles right triangle. And basically here what you could do is you could take the hypotenuse to be 1. So in other words, this is the right angle. And then these two angles are the same. They actually show that the two sides that are equal to each other are, it's actually not hard to show, 1 over radical 2. And because of that, what you get is, since these two equal angles are 45 degrees each, you end up getting what's up here. So they derive that using a right triangle, okay? That's what they do. And now, because of that, you actually get, if you were to draw an angle of 45 degrees in standard position, okay? Like so. So this is the angle, this is 45 degrees. So let me see if I can write that. So, there we go. But they tell you that, but that point P is going to have these coordinates. So P is going to equal to 1 over radical 2, and that's the same thing as radical 2 over 2. It's the same thing, you can just rationalize it. But that's what the coordinates of P are going to have. Okay?